Welcome to Study Loop.
Hello, guys. We're doing problem number 42 in Chemistry Essential Science. This is chapter 5. So, if referring to tables, they want to predict the higher enthalpy in four scenarios. So, broadly speaking, bond formation leads to lower enthalpy, and bond breaking leads to higher enthalpy. So, we can apply that broadly. So in part A, we're dealing with 1 mole of solid CO2 and 1 mole of gaseous CO2. Since solid CO2, the molecules are closer together, so you're going to have stronger IMFs. And in gaseous CO2, the molecules are further away, so you're going to have weaker IMFs. So that means that gaseous CO2 is going to have the higher enthalpy. Now for B, you have 2 hydrogen atoms and 1 mole of H2 gas. Since you have to input energy to break H2 and form hydrogen atoms, then 8 atoms, as H atoms are going to be less stable, and they're going to produce us, and you're going to have them producing a higher enthalpy than H2. Now, 1 mole of H2 and 0.5 moles O2, or versus 1 mole of H2O. Or rather, gaseous water. So, first of all, it's important to remember that when an element in their standard state, they tend to, as at least under standard which means like their most stable state under standard conditions, their delta H is 0. So let's say we're dealing at 25 degrees Celsius, then delta H of H2 and delta H of O2 would be 0. Now remember, bond formation molecules coming together, that is a very stable interaction. So H2 and O2 coming together to form water. That's going to be a spontaneous reaction, especially because, as if you look at the bonding here for H2, both H's and both O's, naturally they have the same electronegativity, so you're going to have non-polar bonding. Now here you have H2O, which has as polar bonding. So your electrons are going to be, from your hydrogen, are going to be pulled towards your oxygen, which is going to create a more stable structure. So the system that has higher enthalpy, that's going to be your 1 mole H2 and your 0.5 moles O2. Now, for 1 mole N2 at 100 degrees Celsius versus 1 mole N2 at 300 degrees Celsius, remember, the stronger your bonding is the lower your delta H value is going to be. So remember, as you increase temperature, molecules become more gaseous in nature. They start to behave more like ideal gases, which means that you're breaking the interactions between them. So generally, a molecule at a higher temperature is going to have a higher enthalpy value because you don't have those favorable interactions. That means N2 at 300 degrees Celsius is going to have a higher delta H than N2 at 100